This video demonstrates the use of the new F3TAP Treadmill Advanced Analysis software package. There are a number of features to this software. On the right hand side you'll see this panel, which is the data viewer. You can use this to load previously collected data trial to have a look at the force, the speed and the centre of pressure. For example, choose Data and Load File and select a previously collected trial. You'll see that the data is loaded into the data viewer, and you can right click on this data to plot, for example, the speed, the horizontal or vertical forces, or all the forces, or the centre of pressure information. We will use this later to determine our speeds at which we will determine our sprint efforts. For example, if we wanted to analyse walking data, we would first be advised to load a walking trial into the data viewer and plot speed as a percentage and metres per second. If we look at our data here, the bottom panel plots our speed as a percentage of the maximum speed attained for that trial. If we increase the size of the chart, we can get a better idea of where the speed efforts lie. In this example, let us consider from 75% up to 100%. We would now open our two walking trials by selecting them. We would change our minimum sprint percent to 75%, our maximum to 100%, and our minimum effort time to 10 seconds. Sampling rate is set at 200. If this sample rate is wrong, the software will automatically correct it. If we select Start, the software will then ask us where we would like to save our results. Depending on the size of your trials, they may take a few seconds to open, but will only take mere seconds to analyse. At the moment, it is opening the trial in Excel. It will save your Excel results based on the version of Excel that your laptop is running. Here we have our results. In each trial, it identified one effort, and we have our summary results in this spreadsheet for the first trial and for the second trial. On the step-by-step sheet, we have a step-by-step analysis for each effort identified in each trial. It has also identified the left and the right hand side. This is useful for diagnosing any deficiencies in the left and right side of your athlete. If we now analyse our jogging trials, we would again open the trials of interest, and this time we will select submaximal efforts. From 45% of the maximum sprinting speed to 75% of the maximum sprinting speed, and we'll change our effort time to 5 seconds. Once again, we will be asked where we would like to save our results. The trials are currently being analysed and written to Excel. Once again, our first sheet will have each effort analysis. Here we can see that in each trial, 2 efforts were identified, and the summary data is again presented in the efforts spreadsheet. And the step-by-step spreadsheet, we have a step-by-step analysis of each effort for each trial, and once again our left and right footsteps are identified. Here is our first effort, for our first trial. Here is our second effort for our first trial, and similarly for our second trial. The data viewer can be used simply to explore the data that you have collected. For example, you may wish to just look at centre of pressure. You may wish just to look at the actual speed profile that your athlete ran. You may also look at the vertical forces, and you may also look at the horizontal forces. Alternatively, you may wish to look just at a selection of data. To do this, simply select the data you are interested in and plot selected data. Note that you must select at least 51 data points. And here is the data that we've selected. Let us now have a closer look at some of the results we just collected. Based on our step-by-step analysis, if we plot the results, we can see that although the work generated per step is about the same for left and right foot strikes, how this is generated is different. We can see that the left foot consistently generates more horizontal force than the right foot on every step. Consequently, the power generated per step, which is derived from the horizontal force, is consistently greater on the left side of the body than the right side of the body.